This is technically the 7th video. Starting up on number 43, we're dividing fractions here, dividing fractions. So before dividing, we could look at the fraction itself and see if you could cancel anything out, if you could simplify. And as you could see, we have x to the 5th up here and x to the 4th down here on this first fraction. So if you wanted to, I recommend that you cancel out all of these 4x's with 4 of these, and you would have 3 left over. No, 1 left over up on top. 4 cancel with 4, and there's 1 left over up on top. So what we really have, let me rewrite this thing. You really have 5x to the 1, or just 5x, over 2. The x is canceled, so it's just y. So you have 5x over 2y. Not only that, I want to take this division sign, and I want to change it to a multiplication sign. You could do that as long as you flip the second fraction. Remember, dividing by a fraction is really multiplication of the reciprocal of that fraction. So you have to flip it. Okay? So we end up with 2y to the 6th over 25. Okay? So now we really have a multiplication of those two fractions. And we could continue canceling with what's alike on top and on bottom. So this 5 right here and this 25 divided by 5 is 5. In other words, this will cancel with this, and you'll have 5 left over on the bottom. Let me do that. The 5 cancel with the 25, you're going to have a 5 left over on the bottom. The 2 on top also cancels with the 2 on the bottom, and there are no 2's left. And we also have one single y down here and 6 of them up there. So one of these completely cancels out with one of these, and you're going to have 5 left over up on top. So our final answer is, what do we have left up on top? We have an x. We also have a y to the 5th. So xy to the 5th is on top. Xy to the 5th is on top over. And what's left on the bottom? There's just the number 5. So you have xy to the 5th over 5. And as you can see, it's not b. Sorry, not b. It's... there you go, D. Boom. So, if you understand that problem, you should be able to do number 44, which is exactly the same, just with different numbers. So we're going to jump to number 45. Number 45, evaluating the piecewise function. This is one of the most recent things we've done. It's as simple as knowing where your input belongs. And knowing where your input belongs depends on the requisite that they give you. Right here it says, use 12 if your input is less than or equal to -1. Use -5 if your input is between -1 and 3, right? Use 5 if your x value is greater than 3. So when we look at the input of -7, -7 is definitely less than, -7 is definitely less than or equal to -1, and +7 is going to not be between these guys, but it's actually greater than 3. So if I did look at the input -7, it gives me the output 12 because -7 works here, so I get 12. And if I look at the input of +7, 7 would go into here, and that would give me 5. So right off the bat, we know that the answer is A. I hope that kind of makes sense. The other ones don't work. Like, for example, if we try B, what B is saying is that the input of -7 gives us 12. And that is true. -7 does give us 12 because -7 is less than -1. So we know it works right here, so we have to use 12. So yeah, -7 gives us 12. But if I try +7, +7 is greater than 3, so we have to use 5. It doesn't give us -5. So B, that would be false right there. When you plug in 7, you don't get out a 5, you get out a -5, you get out a +5. So the only one that really works is A. Okay, so 45, I hope you understood that one. It's the same thing, or it should be the same thing as 46, same concept. You're just looking at where you're plugging in, or where your input actually fits. So hopefully you could do that one and check your answer, see if you get that right. Number 47, we're going to work on 47. They give you f of x function, which is a quadratic trinomial, 6x squared plus 9x minus 3. And they also give you a g of x function. This is just a linear binomial. And what they want you to do is to take the f and the g and subtract them. Right? This is the notation for f of x minus g of x. So if you're taking down some notes right here, you probably want to write it down with the notation that we're more comfortable with, f of x minus g of x. So this right here simply means what we just wrote right here, that you're going to take your f of x function and subtract your g of x function from it. So the f of x function is 6x squared plus 9x minus 3. And we're going to subtract, now check this out, I want to put the minus sign, and I want to put the second function, g of x, inside parentheses. Now the second function, g of x, is negative 2x plus 7. So the reason why I put it in parentheses is because this is a minus problem, and you're going to have to distribute the minus sign into both terms. So when you take that minus sign and put it there and there, you're going to end up with a positive 2x and a minus 7. So now we're able to combine everything that's in red, right? All of this with all of that, let's combine like terms. The first part of our answer is 6x squared, because 6x squared, there's nothing to combine it with. But then you could combine the 9x with the 2x, and that'll give you positive 11x. And last but not least, we could combine the negative 3 with the minus 7. That'll give us a negative 10. And that's our quadratic trinomial answer, which is option B. Right there, 6x squared plus 11 minus 10. I hope that helps you on this one. And of course, you should try on your own number 48, which is exactly like 47, and verify your answer. And moving on to number 49. Again, we have two functions, and this notation, f dot g of x, this is not a circle, all right? If it were a circle, then it would be a compound inequality where you plug in your g inside of your x. So this is not a circle, that's a dot. And a dot represents what? Multiplication. So I would write it in the notation that we're more comfortable with, f of x times g of x. So we're going to multiply those two together, so I need to rewrite the whole thing. 3x squared plus 9x minus 6. That's a trinomial, and we're going to multiply the g of x function. I'm going to put in a different color, which is a negative 6x, running out of space here, plus 9. Now, we are going to have to distribute. I prefer to distribute the binomial into the trinomial. Let me just focus in on this. So distributing the binomial into the trinomial, negative 6x times 3x squared, that's negative 18x to the third. Distributing negative 6x into positive 9x, it's going to be a negative 54x squared. Distributing the negative 6x into the negative 6, it's going to be a positive 36x. And now let's distribute the second term, the 9. 9 times 3x, that's 27x squared, but instead of writing it over here, I'm going to write it underneath the x squared. So 3 times 9 is positive 27x squared, because I don't have to combine them anyway. And then 9 times 9x, that's going to be a positive 81x. And last but not least, 9 times negative 6 is negative 54. And now let's combine like terms. We're going to end up with negative 18x to the third and minus 27x squared, and 36 plus 81 is 117. So we have plus 117 with an x and minus 54 at the very end. So that is our answer when we multiply them together. So that would be option C. Cool? All right, let's move on. So of course, number 49 is exactly like 50. Try 50 on your own, see if you get the correct answer. Moving on to 51. So they give us f of x is, man, can't even tell what that is. Is that x to the, what is that? X to, oh, there it is. That's weird. Okay, so f of x is x to the third, g of x is 2x plus 6. You have a cubic function and a linear binomial. And they want you to do the composite function where you take the f of 4 and plug it inside the g of x function. In other words, working from the inside out. So working from the inside out, you have a 4, you're going to plug in the 4 into the f, and then once you get that answer, you're going to plug it into the g. So let's plug in 4 into the f. So over here's f, we're going to plug in a 4 right here, and 4 times 4 is 16 times 4 is 64, correct? Yes, correct. So f of 4 is 64. And we still have g of 4 to figure out. I mean g of 64 to figure out. So we're going to plug in 64 right in here. So you really have 2 times 64 plus 6. So you have 128 plus 6, which is 134 as a final answer, which is option D.